To determine the derivative of f of x equals 3x cubed natural log x squared, we need to recognize that we have a product of two functions, so we'll apply the product rule, which is given here. So let the first function equal f, and the second function equal g. So f prime of x is going to be equal to f times g prime plus g times f prime, or the first function, times the derivative of the second function plus the second function times the derivative of the first function. So now we'll determine the derivative here and the derivative here. So we'll have f prime of x equals 3x cubed times the derivative of natural log x squared. This is going to require the chain rule where u is equal to x squared, and that formula is given here if you need the review. So the derivative is equal to 1 over u times u prime, or 1 over x squared times 2x. This is the chain rule. I'm going to go ahead and put this over 1 plus natural log x squared times the derivative of 3x cubed, which would be 9x squared. Now let's go ahead and simplify this first product. Notice how two factors of x will simplify out. This simplifies to 1, and this simplifies to x to the first. So we'd have f prime of x equals, this will be 6x squared plus 9x squared natural log x squared. Now we could factor this. The greatest common factor would be 3x squared, which would leave us with 2 plus 3 natural log x squared. Now for this problem, I do want to show how to determine this derivative using a slightly different method. Before we apply the product rule, we could recognize that we could apply the power property of logarithms given here, which means we can take this exponent of 2, move it to the front, and multiply it by the natural log. So we could rewrite the given function as f of x equals, we'd multiply the 2 and the 3x cubed to get 6x cubed times natural log x. And now we can apply the product rule in this form. So the first function is f, and the second function is g. The benefit of doing this is we don't have to apply the chain rule when determining the derivative of natural log x, which means we'll have less simplifying. Let's give it a try. F prime of x is going to be equal to the first function, which is 6x cubed, times the derivative of natural log x, which is 1 over x, or 1 divided by x, plus the second function times the derivative of the first function, which would be 18x squared. Let's go ahead and simplify this. Notice one factor of x simplifies out. This simplifies to 1. This simplifies to x squared. So we have f prime of x equals 6x squared plus 18x squared natural log x. And now we could factor out the greatest common factor here, which would be 6x squared, leaving us with 1 plus 3 natural log x. Now the reason I wanted to mention this is that if we take a look at these two derivatives, they do look different because this has natural log x in it, and the first one had natural log x squared. But if we were to apply the power property for the natural log of x squared, this would become 6 natural log x, which means we could factor out another factor of 2, which would give us the result of method 2. So if you're trying to match an answer in the back of a textbook or in an online homework system, you may see either function as a derivative, and they are equivalent. In the next example, we'll take a look at a problem where applying the property of logarithms to the initial function will be extremely helpful to determine the derivative.